Okay, so we are continuing with acceleration, and this is section 3.2, acceleration due to gravity. Now, imagine we have a ball that's just dropped. So it's kind of free fall dropping, okay? You take this and you just drop it. Let us try our best to draw our xt curve, our position as a function of time. So each of these balls, right, has been captured at the same time interval. So perhaps it's between every 0.1 second we take a picture, every 0.1 second. So every time you see a ball, the change in time between the previous one and it is the same. So we have the same delta t all between every single ball, okay? So what can you see for equal times? What we're going to see is we're going to see something that looks like this. So we have our beginning position, okay? We're going to see something that looks like this. We're going to see a curved motion, right? Okay, just please use your imagination. This is meant to be a curve, okay? So remember in the previous video, whenever we see a curvature of our position time, whether this is a negative curvature, whether it's a curvature like this, or whether it's a curvature like that, right? Whenever we see a curvature of position time, we know that we have some acceleration there, okay? If we just had a straight line for position time, then we know that we would have a constant velocity. In this case, it would be a negative velocity. And because my velocity time is constant, we would have zero acceleration. But because we've got a curvature in our position time, we will have an acceleration. And what kind of acceleration? Well, because it's a negative curvature, we are going to have negative acceleration. Okay. So I'm just going to jump over all of that. Here we see that was what I was trying to draw, is we see this kind of curvature to our position time curve. Then what's happening with our velocity? Although this is not strictly velocity, we're looking at delta x here. Our delta x is a straight line. Remember, our velocity, our average velocity is my delta x over delta t. So my average velocity should follow the same shape as my delta x. So we've got delta x here, but what I'm saying is my assumption is that this is also the same shape as my average velocity. Then what's going to happen with the acceleration? Well, we know that acceleration is delta v over delta t, average acceleration. So we're going to have a negative. There's a negative slope there. Okay. So I think that's good enough. Let's see what we'll do in the next video. Perhaps we'll do a problem.